Go for it.
Alright, I'm Friedman.
I'm Chris, and our project is FaLight, which is French for the FaLight. And essentially we created a program that runs both a light and a fan separately. And for the fan functionality, we had an auto mode, which essentially what it does is it, depending on the temperature of the fan, between 17 and 28 degrees, will affect how fast the fan spins. So if it goes above 28 degrees, it's already spinning at 100%. And if it goes below 17 degrees, it turns off the fan, because if it's cold, you don't want to run the fan. And then we also have a manual speed, which is changed with button 0 that goes from off to high speed, medium speed, and low speed. And then for the light, we have essentially 3 modes: a manual light mode, which just turns it on and off; a strobe light function, which will strobe light, and with button 0 you can, there are 3 different speeds at which the strobe light will flash. And then the last one is the recordable light, which essentially you record in a 5-second sample time, and then when you play it back, it will just loop that 5-second sample.
So here's our overall block diagram, and basically everything, like the ADC, is what we used for the last experiment with the temperature sensor. One thing we added was we added a DC power supply because the DAC wouldn't output enough current to actually drive the fan or the light, because it's only about like 1 or 2 ohms, and so it required like an amp pretty much to run the light or the fan. And so we had to output into the base a bunch of NPNs, and we put 4 in parallel because if we only had 1, they're only allowed to run about half an amp for each one, so we put 4 just so that they would overheat. And but everything else is just what we used in previous experiments.
And our design overview was, for the fan, we basically have a temperature sensor interface in order to get the fan speed to react to the temperature in the room and affect its speed. And then the DAC output with the 4 NPNs is she described so that we could have enough power to run the fan. And then the software basically controls the voltage to the DAC, which will affect the speed and also whether the light is on or off.
So then, since like the temperature sensor, it doesn't change, like the output doesn't change very much over the range that we are using, we had to change the, to kind of just scale down the voltages in the software. Otherwise, the fan speed would change very much if we just directly connected the ADC like up to the DAC. So, and then we also found out that we needed to put in a bunch of NPNs. And the other thing was when we're using the automatic fan speed control, we saw that when you'd actually not put any voltage into it and then you slowly increase it when it was heating up, it wouldn't actually start on its own. So we had to sort of give it like a kickstart voltage when the temperature got above 17 degrees again. Otherwise it wouldn't start, even if it then got up to 28 degrees. So we had to add that in.
So right now it's on, the fan speed is on auto, so depending on the temperature, so go ahead.
So the speed of the fan, and
then as it heats back up, the speed up.
so
And as it warms up more, it gets faster and faster. And then you can switch it to manual mode, which it starts off, and then you can change it to either high speed, medium speed, or low speed. And then for the manual light mode, we have button 0, either change it to off and on. Then we also have the strobe function that also changes with 3 different strobe speeds. And then we also have the recordable light. So essentially what it does on the screen, you push button 3 and it starts it, it counts down. And basically you just it'll tell you it's completed, and then you just switch one down, and it'll just play it back and loop it. And that's it.